Hi guys, welcome to the CATWay. So in this video, we are going to solve our daily set. And before we begin, do not forget to like, share and subscribe. Now, what do we have today is that a car starts moving along a straight line in north direction at t is equal to 0 seconds. The speed time graph for the car is given below for the first 15 seconds, in which it covers a total distance of 320 meters. Now, the bar chart given below shows the distance covered by the car in the next 15 seconds. The speed time curve for the car is a straight line in the time interval 0 to 5 seconds, 5 to 10 seconds, 10 to 15, 15 to 20, 20 to 25, and 25 to 30 seconds. Okay, so for the first 15 seconds, we have been given a speed time graph. Like the distance covered will be actually be the area under the graph. Okay, and then for the next 15 seconds, we have been given directly how much distance it did it cover. Okay, so what do we need first is see. So what do you have is that the distance that was covered in the first 10 seconds if you have to calculate. Okay, so for that, what diagram do you have is this is the diagram guys that you have. Okay, this is a diagram that you have. Now in this, if you see, this part is a triangle, right? This is a triangle wherein this part is 28, the height is 28 and the base is 5, right? So for 0 to 5 seconds, you can calculate the area under the curve. That will be, see, this part won't be counted because this is not where the car is moving. The car started from 0 and kept on a pace and reached the 28 kilometer per second ka mark. So for the first 0 to 5 seconds, it will be the area of the triangle, that is half into base, that is 5 into height, is what you get. Okay, so the total covered in the first 5 seconds is 70 meters. Okay, then from 5 to 10 seconds, when you're talking about, what do you have is you have the height, it's a rectangle, the height is 28 and the base is 5. Okay, so base into height is what you do. So 28 into 5 will give you 140. Okay, 28 into 5 will give you 140. So in the first 10 seconds, the total distance the what is it, a car moved is 140 plus 70, that is 210 meters. Okay, whereas it has been given to us that the total distance covered in 1 to 15 is 320 meters. This is something given to us, right? So what we can conclude from here is that between 10 to 15, the speed of the car was the distance that the car covered was 110 meters. Okay, so between 10 to 15, the car covered 110 meters. Okay, now guys, what do we have is, see, uh up till here, okay, up till here it has covered, okay, up till 15 seconds it has covered, and a total of 320 meters has been covered. Okay, now moving on to the first question. What does the first question tells us? It asks you that what is the speed in meter per second of the car at t is equal to 15 seconds. That means this is the point it is asking about on this particular graph, that how much is it. Okay, how much is it, what is the location of this, right? So with that, we will be able to identify that what is the speed in meter per second. Okay, now if you look closely guys, this is a trapezium, that is what we have. Okay, let me remove all this initial wala. Okay, so what you have over here is that it is a trapezium over here. Okay, the trapezium from here to here, this is the trapezium that we have. Okay, this is the trapezium that we have. Now what do we know is about the formula for the area of the trapezium that we have to calculate. So guys, basically the formula is, let's say, see, this is the base over which you have, the tilted, just a second, this is the base over which you have the tilted part. Okay, so this will be, let's say, A, B and C. Take care. So the summation of A and B will be taken. Okay, the summation of A plus B will be taken and it will be multiplied with the height, that is the C1. Okay, and the entire thing will be divided by 2. So this is what we have. Take care. And this will give you the area. So the area that we know is between 10 to 15 is 110. The area we know is 110, right? And what we know is the value of A is known to us. Okay, so the value of A is known to us. And talking about the value of C, the value of C is 5. This is what is known to us, right? So from here, if you calculate, you will get that B ka value will turn out to be 16. That means the position which this point is the 16 meter per second. So the speed of the car at t 15 seconds was 16 meter per second. That is option number B will be the right answer. Now moving further, okay. So now it is asking what is the speed of car at t is equal to 30 seconds. But before going to that, what we need to calculate is the speed of the car at 20th second, 25th second, and then only we can calculate the speed of the car at the 30th second. Okay. So now what do we have, guys? Let's see what do we have. So after that, in the next 5 seconds, the car covered 60 meters. Okay, in the next 5 seconds, the car covered 60 meters. That means probably it even went lower. Okay, the area, the speed dipped even more, right? Now again, the same logic will be followed. You know this is 16. Okay, you know this is 16. This is 5. Okay, this part you do not know, but the area under the curve is known to you. That is what we have been given over here as 60. Okay, so the same logic will be followed at 16. The sum of the sides between which the tilted part is, that is 16 plus b into the opposite end of the tilted part, that is 5 divided by 2 for the area of trapezium. And this has been given to us as this time as 60. Okay, so if you calculate now, you will find b is equal to 8 meter per second. Or basically, this is the time at time 20. Okay, this is time 20. All right. So now this is what we have. Okay, now between 20 to 25, the car covered 80 meters. Okay, so the car covered 80 meters. So basically what is happening is that car went somewhere over here. Okay, the car went somewhere over here. From the speed went from here to here. Now this is again 5 seconds. Okay, this what you know is 8. Okay, this is what you know is 8. The entire area under the curve is given to you as 80, and this is the part that you have to calculate. So again, via the same logic, that is 8 plus b into 80 into 5, 8 plus b into 5 divided by what is it? Divided by 2, and the area that has been, the distance has been given to us as 80. So from here we calculate the value of b now, and it turns out to be 24 meter per second. Okay, it turns out to be at the, so this mark is basically the 24 meter per second. Okay, and this is what? This is the time at time 25. This is time 25. Okay, so time at 25. Sorry, at time 25, the speed is given. Okay, now what does it tell you? That in the next 5 seconds, the car covered 70 meters, right? So the car has covered 70 meters. That means again there was a dip in the speed, right? There was a dip in the speed. Okay, again what you have is a trapezium. You know this side is 24. This is the time frame, that is of 5 seconds. The total area under the curve has been given to you as 70, so you can easily calculate this part, right? This line. So for this, what do you have is this time 24 plus b divided by 2, and the entire thing be multiplied with 5 is given as 70. When you calculate, you get the value of b as 4 meters per second. And this 4 meters per second is basically the time at 30 seconds. Okay, so what do we have is 4 meters per second. So the speed of the car at t is equal to 30 is option number D, 4 meters per second. Okay, so this is what we have. Now moving to the third question. So the third question is, what is the average speed in meter per second of the car between t8 and 24 seconds? Okay, so guys, between t8, so t8 would fall somewhere over here, right? T8 would fall somewhere over here. Now here the length is same, equal to 28, and the breadth over here is 2, right? So between 8 to 10 seconds, the car traveled 28 into 2, that is 56 meters, right? Then what has been known to us is that between 10 to 15, it traveled 110 kilometers, right? Between 15 to 20, it traveled another 60 meters, right? Now the most important thing that we have to find is, let's write it over here, at time 25, the speed was 24 meters. Okay. Now what we have to find is, the only distance that is left is 20 to 24, right? 20 to 24 is the distance that we have to find. Okay, so let's recreate the graph. Let's say this is the 20 meter mark, 20 second mark, this is the 25 second mark, and this is the 20 second. Okay, this is the 20 second mark. Okay, now at 20 second mark, the speed was, or basically you can say the height was 8 meters per second, right? From there was a jump into the speed. and you know that the speed over here is 20. Okay, the speed over here is 24. But you do not need that height, you need this height, right? The height that you actually need is going to be this one. Okay, so let's give it some names. Let's say it is D, it is D dash. Okay, then this is P, let's say, and this is P dash. So let's say this is what we have. Now what we have to find is we have to find the area between this, right? What we have to find is the area between this. Okay. Now guys, what you know is what we know is that what you can say is that from here coming up till here, okay, the distance is the slant was that there was a rise of 16 meter per second, right? But that 16 meter per second, now every second we will be taking as a uniform rise. Okay, so if for 16 seconds was the total rise, the sorry 16 meter per second was the total rise, and it was divided into 5 single second segments, and we only have to calculate it for the, sorry, this is not 20, this is 20. Okay, this is 20. Okay, okay, so 24-second mark we have to calculate. So we will only calculate the rise of 16 for the 4 by 5 of the second, because total time is 5 seconds. So only for 4 seconds we will be calculating. Okay, only for 4 seconds we are going to calculate that value. Okay, and that will give us this point, the location of this point, and that is basically 16 into 4, that is 16 into 4, that is 64, and 64 divided by 5, that is 12.8, right? So now what do we know is that this point over here is at the 12.8 mark, above 8, 12.8 mark points above 8. So if you add 8 into this point will turn out to be available at 20.8 meters. This point will actually be available at 20.8 meters, because this 16 rise was from here to here, right? So from here to here it is 12.8, but this much also will be added, because this part will also be added, right? It was only from here to here. This part will also, before the earlier part, that is this part of 8 meters per second, or the height, will also be added, and that means the point this is 20.8. Okay, this is at the 20.8 meter. Now you can easily find the area. How? Again, applying the same thing, that we have. Okay, so in this case, what do we know is that let's get the area clean now. Let's get the area cleaned a bit. Okay, so what do we have over here is that this is the height. Okay, and this height had turned out to be 20.8, right? Now what we know is that calculating the area of the trapezium, we need the base. So the base value is 4 seconds, right? 4 seconds. Apart from that, what you need is the sides that contain the tilted part, right? The sum of the sides containing the tilted part. So 20.8 plus 8 will give you 28.8, and this whole will be divided by 2, and you will get the area as 57.6. So between 20 to 24, the car traveled 57.6 meters. Okay, now what we know is that between 8 to 10, okay, what is the total distance that the car has covered? So this is 57.6. Okay, so if you talk about the total distance that the car has covered, it is if 156 plus 110 plus 60 and plus 57.6. What is the average speed, guys? The average speed is basically total distance divided by speed. Okay, sorry, total distance divided by time. Okay, now the total distance that we have covered is 283.6, and the time we have taken is from 24 to 8, that is 16. So divided by 16, and you will get the average speed, that will turn out to be 17.7. So the correct answer for the third question is option number B, 17.7. So this was a pretty good set, guys, and a good set to understand how time, speed, distance, and the graph is being used in your LRDI, and it might come, you might see this set in your mock this side at least once, and if you're lucky enough, you might get it in CAT as well. So now you know how to solve when such a type of set comes, and for that, most important thing that you have to always remember is the area of the trapezium, because that is going to be something that is going to help you over there. Now hope you have understood the set well, guys. Thanks for watching my video.